Hello everyone and welcome to the third part of TinyOS tutorial. In the first part we talked about how to set up or install TinyOS in an Ubuntu installation, and in the second one we talked about how to set up a development environment, so basically a place that you can start developing applications for TinyOS. And in this part, that is the part number 3, we are going to have a quick overview about what is TinyOS and how does application structure would look like, and we are not going to deeply go into details. Immediately after we talked about application structure, we start coding, because I think if you see coding, it's much better than somebody stands in the classroom or talk about like 2 hours about what is TinyOS. It's not going to be helpful. So let's just get started and have a quick overview. Well, TinyOS, as its name suggests, it's TinyOS, and OS stands for operating system. So you can think of it as a small operating system that is intended for making applications on sensor boards, and they usually call them wireless sensor network boards, or we're gonna call them from now WSN, or just simply sensor board. So TinyOS is an operating system that has a programming language called NESC. And what NESC is Network Embedded Systems C. So with help of NESC, that is a programming language that is very like C, as its name suggests, is a derivative of C basically, with slight differences. TinyOS tries to make programming for sensor boards hardware independent. As you may know, there are quite a lot of sensor boards in the market, such as TLSP, Mika-Z, or Intel modes. There's a lot of them. I don't know all of them by heart. And TinyOS tries to make application development for these sensor boards hardware independent. So what it does is, with none to very few changes, you could deploy an application that you have made, for example for TLSP, on an Mika-Z board or on an iMode board. That's one point of TinyOS. And TinyOS, as its developers claim, it makes coding and compiling more efficient. That's something we're gonna see in the progress. So now I'm going to talk about the basic structure of applications in TinyOS. So TinyOS applications are based on components, and component is the unit of code in TinyOS, and you can think of it as an object. Maybe you have already familiar with object-oriented programs like C#, Java, or others. And basically components are individual pieces of software. Then when you put them beside together, then they form your application. And another important part of TinyOS structure is interfaces. Interfaces are intended to connect components to each other and form a relation, and basically form a logic that how components are interacting together, and what are they supposed to do in your application. So for example, if we have component number component A, and we have component B, we can wire them through the interface. So this line would represent interface I, for example, and connects component A to component B. In TinyOS, component interfaces are not one-sided. So for example, if you have a connection from A to B, you could have the connection at the same time from B to A. So interfaces are in two ways in TinyOS. That's something that will become useful in the later steps that we're going to see. So applications in TinyOS are simply called app. If you go to installation folder, you will see a folder there named apps, and there are quite a lot of samples that you can see how the structure of applications in TinyOS are. But basically, you need at least three files. One file would contain your configurations. One file will contain your module. The module is a file that holds your code logic, such as your variables or your interfaces. And last one, you need a Makefile that to tell a TinyOS compiler how to build your application. So I'm going to talk about this again. The configuration file is where that you place your components. The module is where you put your code logic and your variables and your interfaces. So later in the configuration that holds your components, you can wire the interfaces components with the interfaces that you have designed in your module. And the Makefile is the file that tells the TinyOS compiler how to make your program. So let's get started and see what we can do. Okay, the first thing is firing up Eclipse. In the second part of the tutorial, I showed you how to install Eclipse and the TinyOS plugin that is called Yeti. That will make life much easier. Some people would program in just simple Notepad or gedit, but we're gonna use this. It will make our life much easier. So let me remove this project first. We start developing our first TinyOS application by opening Eclipse. If it's your first time, you need to define your workspace. I'm just going to let it with the default one and press OK. And it's always a good thing to check for the kind of perspective we are in Eclipse. So always check this if it's your first time. Go to Window, go to Open Properties, Other, and make sure that your perspective is TinyOS. So let's get started by adding a new project. So I'm going to File menu, New Project. So it will open it with Project Wizard. I'm going to select TinyOS, click Next, and we're gonna name our first project HelloWorld. HelloWorld. And our target is going to be TLSB. So you see there are quite a lot of sensor boards here already, and we're gonna just work with TLSB. So as you can see, Eclipse has made for us a project folder named HelloWorld. And there are two things here, two items. One is the Makefile for the Yeti plugin that we are not going to change it, and there's a source folder. And in the source folder is the place that we're gonna add our files. So I'm going to add a new file here, and my file is going to be a module. So remember, the most simple application in TinyOS should at least have three files: your module file, your configuration file, and your Makefile. We'll start doing this by creating the module file. So I'm going to name this HelloWorld C. So this is a convention, a naming convention in TinyOS, that you give your project name plus C for your module. So I'm going to click Finish. This naming convention is optional if you want the other TinyOS developers to have an easy time reviewing and changing your code. Try to follow this convention. So the template of the module will look like this. We have the module HelloWorld C, and we have the implementation. And what we can do here is start introducing the interfaces we are going to use. So the first thing you will need in almost any TinyOS application is the boot interface, and boot interface is the code that takes care of booting your microprocessor. So I'm going to write uses. It's a keyword when you want to introduce an interface. You need to use the keyword uses, and interface uses interface. This is how you declare interface. And if you press Ctrl space, the Yeti plugin will show you a lot of interfaces that is available in TinyOS. And of course you can make your own interfaces, you can make your own components. That's something for later tutorials. Now I'm going to add the interface boot. This is absolutely necessary. Without that interface boot, you're not going to have some luck. Then, so don't mind this this error. I'm going to tell you why it's there. Then in our first program, that is HelloWorld, is very typical for microprocessors, that when you first time make a program for them, you just want to light up one LED, and this is our case here also. As you may know, the TinyOS compatible boards should follow a standard, and this standard indicates that they should have at least 3 LEDs. And for accessing the LEDs and turning them on and off, there's an interface. Actually, there's a component named LEDs. So we're gonna use this interface, LEDs. Now, why we have this error here? If you hover your mouse over this error, you can see that Yeti plugin is telling you that this interface is missing the implementation for its event booted. So if you know, in for example C#, when you use an interfaces can contain method signatures, and this is the same case here. So I'm going to just click here. The Yeti plugin will take care of that and will implement the method signature that was there. So the interface boot will provide us with an event that is called booted. So this event is going to be called anytime that your sensor board, the microprocessor on your sensor board, is ready to execute your commands and code logic. So this is the place that we want to actually do something. We can make another function, for example, void turn on LED. So we can say that when the chip is ready, the sensor board is ready, please run for us this function. So this is the basic things. And here, when you want to execute the command, then you need to use the keyword call. So I'm going to use keyword call and call LEDs or LEDs dot. You can now see that what kind of methods this interface or this component will provide you. So for example, I want the LED 0 on my board to be turned on. It's just as simple as doing this. Or I could just call this directly in the event, so it doesn't matter really. If you want your code to look good, it's better to separate the methods and functions. So I'm going to keep it like this. So this is the our logic in our code. Now you have to remember that we also need two other things. It's our configuration file. That's basically some place that we can wire these components using these interfaces. That is wiring component boot using this interface, and wiring component LEDs using this interface. So for that I'm going to add a new file here, new. Now this time I'm going to add a configuration. So the naming convention for configuration files is again your project file, project name, HelloWorld in our case, and you have to follow it by app.c. Again, this is just a convention. You can put any name you want, but please follow this convention. And this is how a template for configuration files would look like. We are not going to use this part of code at the moment. Later I will show you what you can do here, but at the moment I'm just going to type do nothing, and it's now time to implement our configuration. So if you remember, in our module we had interfaces boot and interface LEDs. What we can do here, we have to introduce the components. So I'm going to say components, and again if you press Ctrl space, the Yeti plugin will find you the components that is already defined in TinyOS. So again, one of the most important components is the component named main C. So this is your main component. You always would need this, as far as I know. Then we're gonna add another component, components, let's see. So you can see some kind of similarity here. We had two interfaces here, interface boot and interface LEDs, and component main C and component let's C. So this C indicates that they are component. So what is how we're gonna wire them together? We have to make another component here. I mean call another components. Now this time we're gonna call our module here. Our module is basically a component now, so we need it here. We call it components hello. So if you hit Ctrl space again, the Yeti plugin is smart enough to find you the components within your code. So I'm going to call to define components HelloWorld C. And one good thing is there's a keyword named as, and what it does is in TinyOS there are different kind of components. Some components are singleton, that it means that they are unique and you are allowed to only call them once in your code. And some other components are more like objects, that you can have multiple instances of those components. So if you want, for example, use the timer component and you need like 5 timers in your code, you can use the as key and name them differently. For example, I'm going here to call my a project component as app. Okay, now it's time to do the wiring. And how you do the wiring is like this. Let me comment here. So I want to wire my app boot component to main C. So boot is a component that resides inside main C, and I'm going to wire them using the boot interface. And there's another thing. If I write app, you know, it doesn't matter if I write hello world C, because I've already declared it as app. We are not allowed to use it anymore. But if I would not use this as keyword, what I would do is, you know, you see app is not defined. You could just say hello world C dot put, but it's easier to do it like this. So I'm going to change this back. App.put should be wired to main C, and app.lets should be wired to let's C component. So you can hear the boot is connected to main C, let's is connected to let's C. So this is basically everything that we need. So this code will light up one LED of your sensor board. So remember, we have one step further. We have to add a Makefile to tell the TinyOS compiler how to compile our program. So I'm going to add a new file, and the Makefiles are you have to write them with a capital M, and the rest of the letters are in lowercase. Makefile with no extension. Okay, now we have to define the main component that our program is based on. So I'm going to say component equals hello world app C. So the compiler will look to the folder and picks these components, because this is the place that all the wiring and other stuff has been done. Don't mind this error, it's just for Eclipse. And then what we have to do is include the general make rules that TinyOS has. So for that we just need to write this: include $ in the parentheses Makefile, make rules, sorry. Okay, now back to the application structure. We have our configuration file here. We have our module, that is the logic of our code, and it's in our case it's simply turn on one LED. So when the interface boot is fired, I mean the event boot is fired, we're gonna call this function. And there's our Makefile, that we tell the compiler what is the main component that it should look for compiling, and including the general rules. So it's time to compile our code and deploy it on an actual sensor board and see how it does. So I have already plugged in my sensor board to the USB port of PC. I'm going to check if it's present, and there's a command in TinyOS called mouth list. So if you call mouth list, it will tell you the sensor boards that are installed on your PC, I mean connected to your PC. So we can see on the USB 0 we have TLS-B. But before deploying the application on this, you need to give write access to your USB port, and how you do it in Ubuntu is like typing sudo chmod change mode to 666 and the address of your device /dev, in our case tty usb 0, and you might need to enter your password also. Now we have write access to the USB port. Now let's go to the folder that we had created our project. So remember, it was in a workspace folder. I'm going to list the files here. There's this is our project. I'm going to go into this project. I'm going to list the files. You can see just like what we have seen in the Eclipse, we have the file that is made by the Yeti plugin that we are not going to do anything with that, and we have our source folder. So I'm going to the source folder, ls, list of files. So we have our configuration file, we have our module file, and we have our Makefile. So all we have to do is now type make and the name of the sensor board that we are going to deploy this. For example, in this case, I'm going to do it for TinyOS. Okay, we just wrote make TinyOS, and the compiler did the compilation, and our program is actually ready to be deployed on the actual sensor board. So let's see what happened after we asked the compiler to compile our code. So I'm going to clear the window, list the files again. You can notice that the compiler add this build folder in our source folder. So I'm going to build folder and see what's inside. You can see there's one folder in there, and it's called TinyOS. So normally the compiled files, the binary file should be in this folder. Going to this folder, and I list the files. So this is our binary file that we can deploy on the sensor board. So I'm going back to the source folder. Now this time I'm going to make this same project for another sensor board. So I'm going, for example, say make Mika-Z. Now we wrote one program, and now we can deploy it in two different sensor boards. Going to list the files again, going to the build folder again, and list the files again, and you can see we have another folder called Mika-Z. Going to this folder, and you can see it's a little bit different because the Mika-Z processor is different than TinyOS, but TinyOS was kind enough to let us code for one thing and use it on multiple platforms. So I'm going to go back, and let's clear the window. And if you want to clear the previously built applications, you can just call make clean. Sorry, we have to go to the source folder. So you can see the build folder, and in the build folder there's TinyOS and Mika-Z folders. So if I say make clean, the compiler will delete everything that it had previously built. So I'm going to list again. We are back with our 3 original files. Now it's time to actually deploy our program on a real sensor. So what we're gonna do is typing make, this time TinyOS again, but we have to add another keyword or another argument called install. Now you can see the compilation is done, and it's writing the binary file to the TinyOS. Now it's ready, and I can see on my board that the red light is on. Okay guys, as you can see, I have my TinyOS here, and I just uploaded the program that we made together on the TinyOS board, and you can see the LED 0 of TinyOS is on. So this is our HelloWorld project, and if you know, there are two switches or user keys on TinyOS. This is the reset. So if I do that, when the TinyOS is booted, the LED 0 will turn on. Okay, now let's go back to work again. Okay guys, I'm back, and we are going to make something more interesting this time. So we had our HelloWorld project. It was turning one LED on TinyOS, and that's all. But it shows us that what is the structure of application in TinyOS. So it's not that unuseful, but we are going to make a little bit change here, and this time we are going to introduce you with timer interface and component. So for example, I would like my LED to be switching on and off on each 500 milliseconds. So for this, for sure I will need a timer, so I'm going to use timer interface and component. So I'm going to write interface. Again, I press Control space, looking for a timer. Okay, this is the timer interface, and some interfaces and components on TinyOS have a optional or required tag. So I'm going to type here inside here. I'm going to press Control space. You can see the things that you can put here as an tag, but we know that the timer in TinyOS, we have some different timers. We have the 32 kilohertz, that is the time timer, time crystal. We have the millisecond timer and microsecond timer. So this time I'm going to use the T-milli. So, and just same as the components, you can name the interfaces with different names. So I want to call this timer as timer 0. Okay, we again see that there's a red sign here, and if we hover the mouse here, the Yeti plugin tells us that we are missing the implementation of fired event of the timer. So I'm just going to add it. You can see here that Yeti was kind enough to add it for us. So when the timer is tick, timer value has been reached, this event will be called, and we can put our code here to execute something when the timer has reached the value that we wanted. But before that, we have to start the timer, and the place to start the timer is when the put event has been called. So we want, as soon as our microprocessor turned on and our sensor board is ready, we want to start our timer. And remember, when you want to do an action in TinyOS, you have to use the call keyword. So I'm going to call keyword on timer 0, and there are quite a lot of methods here. I want to start periodic, and we can pass an argument of type int 32. So I want to say this, for example. I want, when the sensor board is ready, my timer to be started at the 500 millisecond intervals. So then when the first 500 millisecond reached, I want to call let 0. There's a function here that toggles your LED. So if it was on, it will make it off, or it was off, it will make it on. So the same thing here. So let's have an overview of what we done. We introduced a new interface and component here, timer. We want this timer to be to have a precision of milliseconds, and we name it timer 0. And when our sensor port has been booted, we want to start the timer with a 500 millisecond interval. And when the timer is fired, for example, if it's the first time it will fire, it will be 500 milliseconds since you power up your board, and the next time it will be 1000 milliseconds. And this timer will always this event will be fired, and your LED is going to be on and off with intervals of 500 milliseconds. Okay, we added this interface here, but we have to go back to our configuration file and add it there also. And for that, what we need to do is just declare the component for the timer. So components, just remember this keyword, components, Now, because timer is not a singleton component, but main C is a singleton, you need to use a new keyword. So with the new keyword, we want TinyOS to instantiate a new instance of timer for us. So the component for that is called timer. So you can see we have two kind of different timers here, components, and remember we want it to be in milliseconds, so call this one. So timer milli-C is the component for the timer, and we want to give it name timer 0. And now what we have to do is to wire up this component to with the interface that we had in our module file. So what we're gonna do, call app dot because I haven't saved the file here, let's save the file first. Now the plugin can find the timer for us. So we want to wire this to timer 0. So this timer 0 on this side is the one that we had defined in our module file, and this one is referring to the component that we just instantiated. Okay, now everything should be alright, and I'm going back to terminal window. I'm going to clear the window. I want our previous build to be deleted. I'm going to call make clean, and now I'm going to reprogram the TLSP board. So I'm going to say make TLSP install. Okay, you see our previous application has been erased from the chip. It is the binary file was compiled and it's on the chip. Now if I go over my table, I will show you the result of this program. Okay guys, I'm back to my working table, and as you can see we have the let 0 of the TLSP toggling between on and off state with an interval of 500 milliseconds. Yeah, that's something more advanced than our first program. Okay, you've seen that the let 0 of TLSP was flashing on and off in intervals of 500 milliseconds, just as we defined here. Now for ending this part of tutorial, for having a quick overview, I'm just going to introduce with another timer here. So we're gonna use two timers now. So I'm going to quickly do the same things. Interface, timer, tmilli, and this one I want to call it timer 1. And you can see here again we have this error because we haven't implemented the method signature. Going to add the signature here. Okay, and when the timer 1 fires up, what we want to do to make the second LED 1 of TLSP to be toggled. Okay, and remember we have to start the timer in the boot event. I'm going to call timer 1 dot start periodic. Start periodic for we want to give this one, for example, 250 milliseconds. So there's one step more. We have to go back to our configuration file and introduce another instance of the timer component. So I'm going to say components new timer milli-C as timer 1. I'm just going to wire it like I did before. App timer 1 should be wired to timer 1 component here. Okay, I'm going to quickly build the app again and upload it to the TinyOS board and show you again. So let's again make TinyOS install. Okay guys, I'm back for on my work table, and you can see the latest changes that we have made to our HelloWorld project. We have the first LED 0 turning on at 500 millisecond intervals, and we can see the newest changes that we made to this project. Now the green light that is called LED 1 in TinyOS is turning on at on and off at 250 millisecond intervals, and a red one that is LED 0 turns on at 500 millisecond intervals. So this is to prove you the power of TinyOS. If you wanted to do this thing using the as you may know, the TinyOS is based on MSP 430 from Texas Instruments. If you wanted to do this using the development environment for MSP 430, it was much harder. You had to set the registers, you had to set the watchdogs, and you have to do a lot of much more steps to be able to just turn on one LED on your board. So this is power of TinyOS. It will allow you for quick development and makes life much easier. So I'm going to end the tutorial right here, and in the next parts I'm going to introduce you with some more serious stuff like radio communication. So for example, you can have two of these modes together and communicate between them using the radio chip that is on the sensor board. And serial communication, I'm also going to tell you how you can send data from your PC using the serial USB to the chip. And for example, you can send commands from the PC using the serial port, that is the USB, to the chip, and then from this chip you can send it using the radio to another chip, and you can like this make a wireless sensor network system. Yeah, so I hope you enjoyed this tutorial, and watch out for the next part. Yeah, bye.